Alright, so chapter 11 is where we're going to start, and I will give you fair warning. The stuff in chapter 11 is not hard at all. It's just very time consuming. Very time consuming and very tedious as far as keeping up with your work, as far as keeping up with like signs and multiplication and stuff like that. But, like I said, it's not hard. It just takes forever. So, you have to endure, you have to learn patience, and that's pretty much what this chapter is. It's a good lesson in perseverance and patience. So hopefully you've got it, and if you don't have it, hopefully this will teach it to you. Alright, so what we're going to do is we're going to do systems of equations. In chapter 11, we're going to talk about two different types of systems of equations. We're going to talk about 2x2s, and we're going to talk about 3x3s. Okay, 2 equations with 2 unknowns and 3 equations with 3 unknowns. So the first one we're going to talk about, like I said, is the 2x2. And these are going to be linear equations, so they are straight lines. So a system of 2 linear equations in 2 variables. So a solution in a system of 2 linear equations with 2 variables is a point. So then that's your goal. Your goal is when you solve a system, you're looking for an ordered pair. That ordered pair in particular you'll be able to substitute in that ordered pair into both equations and make it true. Okay? So your goal is to come up with an ordered pair. Now, you know as well as I do, if you have 2 straight lines, you have possibilities. Either one, those 2 straight lines can intersect, they can cross over each other, which is where they intersect, is that going to be that ordered pair? Or they can be parallel, which means they would never intersect, which means there's no solution. Or they can be one line right on top of each other, which means they touch everywhere, which means there's every point of the solution. Okay? So you have 3 different options. Either one, you're going to get an ordered pair, which most of the time you're going to get an ordered pair answer. But if something crazy, if you start working these out and something crazy starts happening, just know it's going to be one of your special solutions, which is going to be either no solution, which means parallel, they're two parallel lines, or infinitely many solutions, which means they're the exact same line. Okay? So just to give you a little bit of heads up. 3 methods to solving a linear system. You can graph these. I do not recommend it. Or substitution and elimination, which are the 2 methods that I do recommend. Okay? The reason I don't recommend graphing is because sometimes when you graph these 2 lines, they're going to intersect maybe not at a definite point. In other words, it would be a fraction or a decimal. There's no way for you to pick out a fraction or a decimal on the graph and it be exact. Okay? So that's why I say don't graph them. Now, when we get into chapter 12, we're going to do systems of linear inequalities. Those I do suggest that you graph. But these, I'm going to show it to you, but I don't want you to use it. Okay? Just so that you'll know how to do it when we get to chapter 12. Alright, so, again, first one we're going to do is this one, and we are going to graph it just so that you can understand, you can get a visual, because I'm a picture person, okay? In order to solve a problem, such as the areas and stuff like that, I have to draw a picture. So, this is a visual of what we're doing. To solve this system, we're gonna graph it, and hopefully it'll come across a good point for us. But if I take that first equation and I graph it, this is in standard form. Do you remember how to graph an equation in standard form? Using your intercepts. Do you remember this? Your x-intercept is going to be 4. Your y-intercept is going to be -4. And so there's that line. And again, this is the problem with this. Can you hit those 2 points perfectly? And using the Sympodium, the answer is no. Oh, too many. Okay. The other way to graph, if you didn't want to use intercepts, is by using slope-intercept form. So remember, you can get y by itself. So you minus 2x from both sides, and you get y is equal to -2x plus 5. And you use your slope-intercept form. So you have -5 or +5 on the y-axis, and then you go down 2 and to the right 1, and you can do this all day long. And so you can see that this line is going to go here. Now, The solution to the system. The solution to the system is the ordered pair where these two lines intersect. Well, when I graph, I'm just going to have to guesstimate. I think that it intersects at 3, -1. But to know for sure, either one, I would have to check my answer in the back of the book, or I can plug 3, -1 into the system. So, for example, and again, for it to be a solution, it has to hold true for both lines, for both equations. So if I plug it into the first one, you have 3 minus a -1 is equal to 4. Well, yes, it holds true there. But then it also has to hold true here. So you have 6 minus 1, which is going to be 5. So 3, -1 actually is the solution. Again, I don't suggest graphing these because graphing is just not the best way to do this. But on your test, which is going to be not next Monday, but the next Monday, so it'll be on the 3rd. I think that's the date. You can look it up. Is that what I told you, Jacob? 3rd. Okay. November 3rd, I think. Like I said, not this coming Monday, but the next Monday. On your test, I'm just going to say solve the system. I'm not going to say solve it by graphing, solve it by substitution, solve it by elimination, solve it by Cramer's rule. I'm not going to say that. I'm just going to say solve the system. Okay? And so you just solve it however you want. So if you already know a method that you learned in high school, go with it. Okay? Okay, substitution. Substitution is a good one to have in your pocket. It's not the most efficient way unless the problem is set up for you to use substitution. But it is a good thing to know. So solve one equation. It's just a roadmap, okay? So to use substitution, the first thing you're going to do is you're going to take either one of your equations, either one that you want to. It's your choice. You're going to solve one of the equations, the one that you chose, for one of the variables. And again, it's all your choice. You take whichever equation you want of the two and solve it for whichever variable you want. I try to avoid any fractions because we hate dealing with fractions. Then what you're going to do is you're going to substitute the result that you got from step 1 into the other equation. And what's going to happen is this is going to create a single equation with a single variable, and you know how to solve this. We learned how to do this in basic algebra. Then what you're going to do is you're going to take the solution from step 2, and you're going to plug it into either one of the original equations to find the other variable. And that's going to be your solution. Okay? Remember the possible solutions to a linear system, because sometimes you'll get an ordered pair, sometimes you'll get no solution, and sometimes you'll get infinitely many. So like I said, when you start working these things, go crazy. Okay, so look at this one. And I'm going to give you some hints. You don't have to take my hints if you don't want to. Again, you can choose either one of these equations and solve for either one of these variables. And it's up to you, okay? Like I said, I try to stay away from fractions. So when you try substitution, what I say is pick an equation that has a variable of a coefficient of 1 or -1. So do you see the one that I'm going to go with? I'm going to go with the top equation, and I'm going to solve it for y. Okay? You don't have to do that, but if you don't, you're going to get fractions that you're going to have to deal with, which is fine. You're still going to get the same answer if the fractions don't bother you. But, again, my little hint is pick an equation that has a term that has a coefficient of 1 or -1. So I'm going to take this one, and I'm going to solve it for y. So I'm just going to move it out to the side and show you all the algebra. You should know all the algebra, but I'll show it to you anyway. So we'll minus 2x from both sides. So we'll have -y is equal to -2x minus 21. And then, of course, we don't need a -y. We need a positive y. So we're just going to multiply through by -1. Basically, change all the signs. And now you have it. So I took that top equation and I solved it for y. That's step number 1. Step number 2 says to take this, y equals 2x plus 21, the solution that you got for step number 1, and plug it into the other equation for y. So this is what I'm going to do. I'm going to take this 2x plus 21 and I'm going to plug it into my other equation for y. And so this is what it's going to look like. We're going to have 4x plus 5 times 2x plus 21 is equal to 7. Now look at what you've done. We have an equation that only has x's in it. And you should know how to solve this. You learned how to do this in basic algebra. So we'll have 4x, distributive property, 10x plus, what is that? Maybe?
Yep.
Combine like terms. And then solve. So we have 14x is equal to negative 98. Is that right?
Yep.
Divide by 14 and we get x is equal to
Negative 7.
negative 7. Now, what should your solution look like? What is your solution to a system? An ordered pair. It's an ordered pair. An ordered pair is comprised of how many numbers?
2.
2. Which one do you have?
I mean, X.
You have x, so you have the first one. You have negative 7.
Negative 7 into the original equation.
Right.
Solve it.
So you're going to take negative 7 and plug it into either one of your originals. Either one of your originals. Let me show you another little trick. Okay, I showed you one trick. Let me show you another trick. Another trick, do you agree that this equation is this one manipulated? Yeah. What variable do we need? Y equals. Yeah. That's your other trick. So we're going to have y equals 2 times x is negative 7 plus 21. So we have y is equal to negative 14 plus 21. So y is equal to what? Again. So you get negative 7, 7. Okay? So again, here's your steps. Step number 1, take either equation and solve it for a variable. Step number 2, take it and plug it into the other equation for that variable. Step number 3, plug what you got from number 2 into any of the originals and solve down for the other variable. And there you have it. All right. Again, substitution methods, like I said, is good to have in your back pocket for problems such as number 11 and 13. Like I said, you will have one of those on your test. So it's just good. It makes things a little bit easier. Elimination method, this is what most people prefer. Okay? Elimination by addition. This, like I said, this is what most people prefer. Step number 1. There's going to be a lot of terminology, so just make sure you pay attention. Make the coefficients on either the 2x's or the 2y's the same. Okay? Opposites, actually. So in other words, you either want 3 and negative 3, or negative 3 and 3, or 6 and negative 6. You know, you want to make opposites. And you're going to do this through multiplication. Okay? So make the coefficients on either your 2x's or your 2y's opposites by multiplication. Okay? You're going to multiply one or both equations by a number or numbers to create opposites. You're basically making LCMs, least common multiples. Okay? That's basically what you're doing. Least common multiples. Doesn't have to be necessarily the least, but that's probably the easiest one. Okay? So, once you've made opposites, then what you're going to do is you're going to add your two new equations together. And when you do that, one of your variables is completely and totally gone. Because when you add opposites, it goes to 0. And so you're just going to mark them off. And then once you do that, you can solve for the variable that's left. Once you have that variable, you go back to substitution. Basically, you take what you have, substitute back into your original, and find your other. Okay? So watch this. I have 5x plus 2y is equal to 10, and 3x plus 5y is equal to negative 4. Now again, it's your choice. It's completely and totally your choice. You can either choose to make your x's opposites, or you can choose to make your y's opposites. So follow me here, okay? If I choose to make my x opposites, I'm going to make them opposite 15. Do you understand where that comes from? 15 is the LCM between 3 and 5. Smallest number that both of those will go into. Okay? If I choose to get rid of my y's, I'm going to make them opposite 10. One's going to be positive 10, one's going to be negative 10. Okay? Now, which one do I choose? That's completely and totally up to you. Whichever one you want to do. We'll get rid of the x's just because there's no rhyme or reason. Just because. Alright, so again, I'm going to get rid of the x's, so I'm going to make them opposite 15. So I'm going to make this whole entire equation. Notice that I encompass the whole entire equation because a lot of people forget to multiply the constant. Don't forget the constant, okay? So I'm going to multiply this top equation by, I'm going to say negative 3. And I'm going to multiply this bottom equation by 5. Now, could I have multiplied the top equation by 3 and the bottom equation by negative 5? Yes. Okay? And again, it's your choice. As long as you're making opposites, it's your choice. Alright? So, let's multiply the top equation through by negative 3. So, we'll have a negative 15x minus 6y is equal to negative 30. And then we'll take the bottom equation and multiply through by 5. So we'll have 15x plus 25y is equal to negative 20. Step number 1 is complete. Step number 2 says to add the two equations together. So when I add negative 15x and positive 15x, those go away. And then negative 6y and positive 25y is going to be what? 19y? Is equal to negative 30 and negative 20 is going to be negative 50. Alright, so now we're going to solve for y. So we'll divide by 19. And we're going to have y is equal to negative 50 over 19. Could you ever pick that off of a graph? This is why I say don't graph. Don't use the graphing method because the y-coordinate of negative 50 over 19 would be near impossible to pick out. Okay, so now, again, we're looking for an ordered pair. Negative 50 over 19 is my y-coordinate. To find the x-coordinate, you're going to take that negative 50 over 19 and plug it into either one of your original equations. Okay, that goes back to substitution. Take your negative 50 over 19, take the y, and plug it into either one of your original ones. Doesn't matter which one, it's going to be horrible either way. So I'm going to choose the bottom one. So we're going to have 3x plus 5 times negative 50 over 19 is equal to negative 4. Now, again, it's your choice. If you want to take negative 50 over 19 and plug it into the top equation, you can. Like I said, it's calculator, calculator, calculator. So we're going to have 3x is equal to 5 times negative 50 over 19.
I did it. I came up with negative 13 and 3 over 19. Mixed number.
Okay, I'm going to do it just in case, okay? Alright. Why am I not going to do this one? Alright, I'm going to do, I mean, you can use the mixed number if you want to, but I'm just going to go with the improper fraction. So we have negative 250 over 19 is equal to negative 4. Alright, so let's solve for x. We're going to add 250 over 19 to both sides. So we'll have 3x is equal to I come up with 174 over 19. Yes, no? Divide both sides by 3. And I come up with 58 over 19 for my x-coordinate. Do we agree or disagree? And like I said, if you want to do mixed numbers, that's fine.
How did you get your mixed number?
In your calculator, it's when you do 5 times negative 50 fraction button.
Mine goes straight to the next one.
It's going to go negative 13 and 3/19. Is that what you have on your calculator? Negative 13 and 3/19. If you look right above your fraction button, it should have, I think, yours. It may just have an improper fraction, or it may have an A B over C to DC. Either way, you're going to have to hit your shift and then fraction again, and it should change it for you. Anything else? So again, fractions are possible, but you have your calculator, so you can deal with it. It's fine. All right, before we go to the 3x3, systems of 3 linear equations and 3 variables. What's going on here is instead of being 2D, which is your lines, you're looking at 3D, which are planes, okay? And if you've ever graphed three-dimensionally, you know that you go from the XY axis to X, Y, and Z. So you just draw things out three-dimensional. For us, Cal 3, if any of you are going on up through the calculus, Cal 3 is where you get into the three-dimensional stuff. It's so much fun. I love it. But if you look on page 611, you'll see pictures of these three-dimensional drawings. And you'll understand that we are talking about planes instead of lines. Now you still have the option of your planes can intersect, such as figure A, and figure B actually. They can be parallel to each other, which would be 11.7, I guess, A. And they can all be the same plane, which would be figure 11.6. So you still have those options. But this time, your solution is not going to be in order of pair, but in order of triplet. Okay, so we need 3 numbers. All right, so we're going to have ordered triplets. So here is your process. It's elimination. Okay, when you solve a system of when you solve a 3x3, it's elimination. All right, so what you're going to do, follow the roadmap. Okay, follow the roadmap. You're going to select any 2 of the 3 equations and then eliminate one of the variables. We just learned how to do that. You're going to make your opposite LCMs, okay, to create a new single equation in 2 variables. So now you're going to have one of your variables is going to be gone. Now, this step number 1 is completely and totally your choice again. You pick the 2 equations and you pick the variable to get rid of. It's your choice. All right? But after that first step, you don't have any choices anymore. You chose your path, just like life. You choose your path, you got to stick with it. Consequences or no, okay? Step number 2, you're going to select a different pair of the 3 equations and eliminate the same variable. You don't have a choice anymore. You got to eliminate the same variable. Now, in this step, you're going to choose, obviously you only have 3 equations, okay? In the first step, you chose 2 of them. So in the third step, you're going to use one of the same and the other one that you haven't used. Okay? You have 3 equations. In the first step, you use 2. In the second step, you're going to use one of the same and the other one that you haven't used yet. Okay? So that kind of looks like I'm shooting her. I'm not shooting her. Okay. So, and eliminate that same variable. Then, you now have made a 2x2. And I just showed you how to solve a 2x2. Okay? So after the first 2 steps, it's back to doing what you know how to do. Okay? You solve your 2x2 and you just back substitute from there. Okay? So watch this. Here's your 3x3. Now again, my little hint that I gave you still holds true. Look for those coefficients of 1 or -1 because those are the easiest ones to do. Alright? So I'm definitely going to use this top equation. Actually, I think the first thing I'm going to look for is opposites. I don't see any opposites, do you? That would be the first thing you look for. And if you don't see any opposites, then use your coefficients of 1 or negative 1. So we can either use the top equation or the bottom equation. Okay? I think I'm going to use the top equation and the middle equation and get rid of my z's. That's just my choice. You don't have to. Your other option, I think, would be the middle equation and the bottom equation with your y's.
You can't do the top and bottom.
You can use top and bottom if you want to, but you have to choose either the z or the y, not both. Okay? Okay, my choice. Just my choice. I'm going to use the top one. Well, I'm going to go ahead and do the multiplication then. I'm going to get rid of z's. I'm going to use the top two. And I'm going to get rid of the z's, so I'm going to make opposite 4s. I already have opposite signs, so all I have to do is multiply that top equation by 4. Okay? So I'm going to have 12x plus 8y minus 4z is equal to negative 44. And then that middle equation is good to go. Check my math. I would hate to miss a sign. Alright, so we're going to add these two together. And I'm going to have 14x plus 5y is equal to negative 33. Now what I have to do is I have to incorporate the equation that I haven't used yet, which would be the bottom one, right? And one of the ones that I already have used, obviously I'm going to choose the top one, okay? So this time I'm going to make the z's go away. I have to make the z's go away because I made the z's go away here. So I have to make the z's go away in my next step. So I'm going to use this first equation and the bottom equation to make my z's go to what? Opposite what? 2. So they have the same sign. So this time I have to multiply 3 by a negative 2. So we're going to have negative 6x minus 4y plus 2z is equal to 22. And then that bottom equation, just write it down because it's got what I need. And then we're going to add them together. So we'll have x minus 3y, z's go away, is equal to, what, 5? And again, that was my choice, whether it be good or bad, that was my choice. I chose to get rid of the z's. Yes, thank you. See how easy it is to lose those signs? Be careful with that. Okay, look what I've done. I've made a 2 by 2. Let's write that 2 by 2 down. I have a 14x plus 5y is equal to negative 33. And I have negative x minus 3y is equal to 5. You know how to do this. You know how to solve a 2 by 2. We just worked, I don't know how many problems. Okay? Solve this 2 by 2. You solve this 2 by 2. Go. You know how to do this. Alright, so solving that 2 by 2, again, I chose to get rid of the x's because I already had a negative 1. Beth said that she did substitution. In other words, she took that bottom equation and solved it for x. She took that bottom equation and solved it for x and then substituted. That's fine too. However you want to do that, that's completely and totally up to you. Either way, we know that y is equal to negative 1. But remember, your answer is going to be an ordered triplet. Your answer is going to be an ordered triplet. And that ordered triplet is x, y, z. So y is negative 1. Now we need to find the x and the z. But from here, once you have one variable, it's gravy. It's so easy. Okay? Watch this. I'm going to take this negative 1, and I'm going to plug it into one of my 2 by 2s. And it doesn't matter which one. Okay? I'm going to take my y equals -1 and plug it into either one of these 2 by 2's. I think I'm going to plug it in here. So I'm going to have -x minus 3 times -1 is equal to 5. And so you can see that I'm going to know what x is once I do this. So we have -x plus 3 is equal to 5. -x is equal to 2, so x is equal to 2. Yes. Thank you. Okay, so now I know x and y. How am I going to get to z? Plug it into the original 3. Any of the original 3. Plug your x and your y into any of your original 3. So I think what I'm going to do is I'm going to plug it into that very top one just because. So we're going to have 3 times x is -2 plus 2 times y is -1 minus z is equal to -11. It's the ugliest z I've ever made in my life. Okay. So we have what? -6 minus 2 minus z is equal to -11. So we have -8 minus z equals -11. So if we add 8, we'll have -z is equal to what? -3. So z is equal to 3. Okay, and again, you have to just follow the roadmap. I mean, like I said, these problems are not hard. They're just long and drawn out. And you've got to keep up with your signs. You notice I missed signs twice in this one problem. But again, if you don't come up with the answers in the back of the book, or if you're just feel like you're going crazy, step away, come back, don't erase, don't scratch out, go through your steps, and see where you missed the sign, okay? So let's go through this one more time, all right? First step, choose 2 equations and eliminate 1 variable. So I chose the top 2 equations, and I chose to get rid of the z's. To do that, all I did was try to make opposite 4s. So initially, before I erased it, I multiplied through by 4. All right, add them together, and I have an equation with 2 unknowns. Then you're going to choose one equation you've already used and the other equation you have not used, and eliminate the exact same variable. So to do that, I had to multiply through by -2. What happens when you do those 2 steps is you make a 2 by 2, and right here it is. You know how to solve a 2 by 2. Okay, we've already done that. I got rid of the x's, so I multiplied through by 14, and I solved down for y. Once you know a variable, you're going to take that and plug it into either of your 2 by 2, solve down for the other variable. Once you know those 2, take it back to a 3 by 3 and solve for the remaining 3rd variable. You and probably about other half class. I multiplied through before I erased it. I multiplied through by 4 so that I could make these 2 opposites. I did for my second step. First step I multiplied through by 4. My second step I multiplied through by 2. Actually a -2.